Good morning. The purpose of this screencast is to help you learn how to find the equation of a line when given certain information about that line. We're going to start with a simple reminder about your two forms that you've studied so far of a linear equation. You've got your standard form, which is ax plus by equals c, and you've got the perhaps more useful slope-intercept form, which is y equals mx plus b. Remember, in that form, m is the slope, b is the y-intercept, and so that's the form that we're most likely going to be using in examples like this here in section 8.5. So our first example is going to be find the equation of the line when you're given the slope is, let's see here, we'll make this a slope of 2 and a y-intercept of 3. Should be pretty straightforward. We're just going to plug in for both of those values in that slope-intercept form. We're going to plug in for the m value our slope of 2, and we're going to plug in for the b value our y-intercept of 3. So it will end up being y equals, our equation will be y equals 2x plus 3. And that's all you have to do. Now, if, for instance, you were asked, hey, put that in standard form, then that's just an extra step of saying, hey, get the x term over there by the y term. So we would subtract 2x from both sides. Negative 2x plus y equals 3 would be putting it in standard form. Either one of those would be acceptable, and usually the information given will tell you which form they want if they want a specific form. So that's a first example that's very simple, straightforward. Your second example will be a little bit more challenging. We want to find, again, the equation of a line, given this time 2 points on that line. So given the points negative 2, 5, and 4, 8. Those 2 points on our line tell us that first and foremost, we need to find the slope. We need to find the slope. Now, you'll remember back from our earlier discussion on the standard form and the slope-intercept, there's also a formula for finding the slope between 2 points. The slope equals y2 minus y1 over x2 minus x1. We also call that delta y over delta x, or rise over run. And it really doesn't matter which we call our y2 and our y1 as long as we are consistent in working them. So I'm going to start by saying, okay, the slope is going to be, I like to take the bigger number and minus the smaller number. So I'm going to say 8 minus 5 as my numerator. So 8 minus 5. And then I come back and I say, okay, I'm going to start at that same point that I started with earlier, and I'm going to say 4 minus negative 2. Notice the use of the parentheses there. Make a note that if one of the coordinates is negative, it's helpful to put parentheses around it. And so 8 minus 5 being 3 up top, 4 minus negative 2 becomes 6 on the bottom, so our slope simplifies down. 3 over 6 simplifies down to 1/2. All right, so we found our slope. Now what we want to do, and this is the interesting part, we want to take our slope-intercept form, y equals mx plus b, and we want to plug that slope in. We just found the slope, so we just found m. So now we know y equals 1/2 x plus b. And what we want to do now is we want to note that there are still 3 unknowns at this point. Okay, there's still 3 unknowns. And this is where it gets a little bit interesting, because actually x and y constitute the coordinates of any point on the line. All right, so this is any point on the line. And we happen in our given information to be told 2 such points. Now, I would suggest using the ones, if there is one, where both coordinates are positive. So I'm going to use the point 4, 8 to plug in for x, y. Now, you could choose either point, but I'm going to suggest letting x be 4, okay, and letting y be 8. So this becomes 8 equals 1/2 times 4 plus b. And this b value now is our final last remaining unknown. So what you're doing is that from your slope-intercept form, you're plugging in the slope that you calculated in the first step. And then you're taking the given x and y values, and that allows you to solve for that remaining unknown b or y-intercept. So all we have to do now is work out the arithmetic down here at the bottom. We've got 8 on the left. 4 times a half would be 2. So 2 plus what equals 8? We could either use inspection or we could subtract 2 from both sides. Regardless, we get b equals 6. And so that allows us to put together our final answer here. So the equation would be y equals 1/2 x plus 6. Y equals 1/2 x plus 6. And that is the line that passes through both of these two given points. And you'll learn next year in geometry that through any given pair of points, there exists one line in a plane. And so this is the line that we just found. Now, I like to give a nice summary of what we just did to wrap this screencast up. So our first step when given 2 points was to find the slope. Our second step was to plug the slope into slope-intercept form for the m value. And then also, let's see if I can copy this part. There we go. We want to plug the coordinates of one of the given points into slope-intercept form for x and y. And then the last step was to solve for the remaining, if I could type, unknown, which is the b value. Writing your answer as y equals mx plus b. Now you know the m and you know the b. Always leave y and x as variables in your answer. All right, and that would be how to find the equation of a line when given 2 points. And with that, hopefully you guys pause the video there if you're still taking notes on that. You can kind of get caught up. That's how you would work one of the examples like this where you're given 2 points. A very common question, and so hopefully that answers that issue for you guys. So this will be the end of the screencast where we've been talking about finding the equation of a line when given either the slope and the y-intercept or 2 points on the line. So thank you very much.